Welcome to Chapter 2 in 20-1. This is all about 2.1 angles in standard position. So there is a bunch of different learning outcomes here. We need to know how to sketch an angle from 0 to 360 in standard position and determine its reference angles. So you're going to learn the word reference angle, you're going to learn standard position today, and you're going to learn how those things relate. You also learn determining the quadrant in an angle with an angle in standard position terminants. Okay, so lots of new phrases and definitions coming at you at once here. We're going to be able to determine the exact values of sine, cosine, and tangent ratios for a given angle with a reference angle of 30, 45, and 60. And this will be using special triangles. Okay. These special triangles you do not have to memorize, you just have to know how to use. They will be given on your formula sheet. So if you don't have a formula sheet, please print that off. Okay, so investigation. Obviously this doesn't really apply to us too much, but angles occur in many everyday situations. With a partner, try to name as many occupations that need to use angles. Just to kind of get your brain moving a little bit, there's a ton of different jobs that deal with that. A big one is actually physiotherapy. Lots of people don't think about physiotherapy as an angle-related field, but physiotherapy, you have to know your range of motion. You have to know there's an angle there and there's an angle there. Those aren't just like super strong shoulders or anything. Range of motion is really important. How your mechanics of your body moves is super important. Of course, engineering, that one's just an easy, old, boring one. Everybody knows engineering uses angles, but some fun ones as well would be like being a chemist or chemistry, because as you get into higher levels of chemistry, you will learn that molecules actually put themselves in different orientations, and you have to know the angles at which they deflect and attract each other. So that's kind of cool. So yeah, there's a bunch of different reasons why we need to know how angles work. So let's move forward. Let's look at some key ideas here. So in geometry, an angle is formed by two what's called arms with a common angle. So of course, in order to make an angle, you just need two arms. Now, within Math 20-1, we really focus on specific arms. So understand what the positive x-axis is. As a little review, you have an x-axis and a y-axis. So what we're going to be doing is we're going to be talking about angles in terms of being on a Cartesian plane. That word might look unfamiliar to you, but it's actually something you use every time you look at math. A Cartesian plane is what you put on graphs. So this is the Cartesian plane here. So without even maybe knowing what a Cartesian plane is, you have definitely seen and used one a ton. Okay, so there's our Cartesian plane, and we can create angles on here. So the positive x-axis is an important thing on your Cartesian plane because it's known as the initial arm. And we will learn angles that are measured from the positive x-axis is a special type of angle. So this would be the negative x-axis up here. Then you have your positive y value. And I guess let's just add on to our value here. That's a little too big. This one should work. There. That's a little big too. Let's use this one. There we go. That works pretty good. So you would also have it going down there, and that would be your negative y-axis. Okay, so this is all things we should know from previous math courses. Now, again, what's important is that the positive x-axis is known as the initial arm. And then when you extend an arm that measures out, this angle is called the terminal arm. So that's found right there. And now whenever you create what's called a vector that has a line, an arm, so let's maybe just use the word arm. In physics class, you might learn that this is called a vector. But right now, when we create an arm that's attached to what's known as the origin point, okay, so another word you will want to remember, here is your origin point. An origin point is 0 and 0. When you have an arm that's attached to the origin point and then extends out, it creates an angle with the positive x-axis. Okay, and this angle is an important angle to understand. This is known as a standard angle. Okay, and we will define what a standard angle is later in the next page, but for right now, you just have to know a standard angle is an angle formed between a positive x-axis, so the initial arm, and your terminal arm. Now, some things to note. If an angle of a rotation is counterclockwise, then the angle is negative. Or sorry, positive. Whoops. So counterclockwise, if you think about a clock and you have your arm here and your little time there, okay? Counterclockwise is actually going this way. Okay, so this would be counterclockwise. And then if you have a angle that's measured going this way, that's known as clockwise. Us millennials might not even know what that means because who the heck sees a clock that looks like that anymore? Just kidding. But I guess the Apple Watch does have that version where you can see a hand type of clock. Anyways, so when you have a positive angle, it's when you're measuring it counterclockwise. So for a really quick little example, we'll get more used to it later on. But for a very quick example here, if we extend an arm up this way, so this is now our terminal arm, and then again, where would our initial arm be? Our initial arm is always found here on the positive x-axis. We could create a negative angle, or sorry, positive angle. So if we measure the angle here, let's say that this is positive 150 degrees. If I measured it the other way, so from our initial arm this way, this angle would be a little different. This angle would equal, and we'll learn about this later, but that's 360 minus 150. That'll be 210 degrees, but it'll be negative, okay, because we are measuring it clockwise. Okay, so that's what we mean by counterclockwise and clockwise. So this is negative because clockwise. This is positive because counterclockwise. Okay, so a few things to note there. So make sure before we move forward, you kind of pause, read over this examples, and get familiar with it because moving forward, you need to know all of these terminologies to do well. So let's move on. Now, let's kind of analyze standard position versus non-standard position. So first off, let's put some definitions to it. So what is standard position? So maybe we'll do this. Standard position angle. So a standard position angle is an angle formed from a positive x-axis, aka an initial arm, and a terminal arm, that starts at the origin. Okay, so that is a standard position. So again, in order for something to be in standard position, your start, so this is kind of a silly diagram because this should actually be connected to that point right here. So it should look like this a little bit more. But again, formatting apparently hates me. But that's what a standard angle is. It's an angle made by an initial arm at the positive x-axis and the terminal arm where the origin point is. So this one is a standard position angle. So here is our standard position. Standard position angle. Because again, our initial arm is on the positive x-axis and our terminal arm starts at the origin. This one isn't. This is a non-standard angle. So it does start at the origin point, but this angle is formed between two arms where neither of them is the positive x-axis. So one of these arms must be a positive x-axis in order to be a standard angle, which it clearly is not. So that's the issue here. So your initial arm, let's maybe write that in a different color here. Your initial arm is not the positive x-axis. And in order to be at a standard angle, you need to be measured from the positive x-axis to your terminal arm that is starting at the origin point. Okay, so I could draw another standard angle here, maybe in purple. I could do this. And this would form a nice standard angle. It would just be measured here. So there's another standard angle. Okay, so there's another standard angle here. As we can see, the initial arm that it's measured from and the terminal arm, your angle is being formed by the positive x-axis and a terminal arm that is at the origin point. So if that doesn't make sense to you, you definitely need to pause, maybe quickly watch a few other videos, read something online, or maybe ask your teacher. Because this will be a pretty tough unit if you don't get that portion. So let's move on. So using the grid paper, aka the Cartesian planes, so let's maybe put Cartesian planes. Sketch each angle in standard position. Which quadrant does the terminal arm lie in? So this is a new definition here. What are quadrants? Quadrants are the sections of a Cartesian plane. So this top right, this is quadrant 1. This here, this would be quadrant 2. This here would be quadrant 3. And this here would be quadrant 4. Okay, so you have 1, 2, 3, 4. Another way that you might see a textbook or something online note is they might say this is quadrant 1 and they use Roman numerals. This is quadrant 2, this is quadrant 3, and this is quadrant 4. Okay, so two different ways to represent the same thing. So now let's look here. So when we're dealing with our angles, some things you need to note. When we think about a Cartesian plane, we want to think of this as 0 degrees. And then the angle that's made between your positive x-axis and your y-axis, that would be 90 degrees. So you can see here, that makes it a 90-degree angle. And then furthermore, if this is our initial arm and this is our terminal arm, you can see that that will create a 180-degree angle. And then finally, if we go all the way around, starting from our initial arm, which is always the positive x-axis, and we go all the way around, that's going to be 270 degrees. And then if we do an entire full rotation, then we are dealing with 360 degrees. So if we go all the way around, this could be 360 degrees. So that's really important to know, and we can place different angles within here. So whenever you come to a question, you want to list those really useful angles. So this is 0, 90, 180, 270, and then all the way around would be 360 degrees. And now at this point, we want to look, and we are sketching 75 degrees. So 75 degrees is obviously between 0 and 90. If you go straight up, right in the middle, that's 45 degrees because it's the half of 90. So it looks like 75 degrees might be a little bit higher than half. And here we have 75 degrees. Okay. Now, which quadrant does this lie in? Well, it lives in quadrant 1, right? So 75 degrees exists in quadrant 1. And you're done with that question. Let's look at 110. So again, right off the dot, I'm going to list all of my relatively important angles. And now 110, well, that falls between 180 and 90, and it's only 10 degrees off 90 degrees. So clearly, if I were to draw this standard angle, it's going to look something like this, where we're pretty close to 90 degrees. Because I mean, the angle here, not 10 degrees, sorry, it would be only like 20 degrees. Okay, so this standard angle here would be 110 degrees. And again, why is that the standard angle? Because we are measuring it from the positive x-axis, which is the initial arm, and our terminal arm is attached to the origin point. Okay. Now, where does this terminal arm lie? Well, we can clearly see it lies in quadrant 2. So here, this exists in quadrant 2. Done. Now 330, again, get used to just noting every single angle that's important here. And what are these angles called? It's important to know that. They're called quadrantal angles because they split up the quadrant. So that's something to kind of note maybe down here. So our 0, 90, 180, 270, 360 degrees, these are known as quadrantal angles. So really useful stuff. Now at this point, 333 degrees, where does that lie between? It lies between 270 and 360. And it actually lies roughly kind of in the middle. Now, in the middle here, that would be perfectly in between 360 and 270. So let's just figure out what that is. So this would be 315 perfectly down the middle. So we're going to be a little bit closer to 360. So roughly around here. And it doesn't have to be perfect as long as we're fairly accurate. So now at this point, we have our angle, our standard angle, which is measured from the positive x-axis, going all the way around counterclockwise. And this angle here is 330 degrees. Now ask yourself, which quadrant does this live in? It lives in 4. So here we exist in quadrant 4. Okay. So that's some really good stuff to know. It's just simply putting out your standard positions, okay? If you don't understand what we just did here, please pause, maybe read a bit in your textbook, ask some questions, fire an email off to your teacher, because if you don't understand this, moving forward is going to be a little tricky. So, angle in standard position. Let's kind of just fully define this. The position of an angle with its vertex at the origin point, or we can just simply say origin of a coordinate grid, and an origin, again, is 0, 0, coordinate point 0, 0. So the position of an angle with its vertex at the origin of a coordinate grid and its initial arm fixed on the positive x-axis. And there we now have our nicely laid out definition. So now at this point, it says create a coordinate plane, then label its quadrants and the angles that encompass each quadrant. So this is already what we've done. This is what's known as the quadrantal angles. So this is asking for quadrantal angles. So again, it's kind of just solidifying you really want to remember these angles. They will help you immensely moving forward. So again, you have your positive x-axis here, your positive y-axis, your negative x-axis, and your negative y-axis. And if we were to put some angles on here, this would be 0 degrees, 90 degrees, 180 degrees, and 270 degrees. And then I guess all the way around is 360. So you might want to tattoo that on your forehead and remember it from here on out, okay? Obviously don't tattoo it on your forehead, but just remember it, okay? We don't need anybody taking that too seriously. So we can see here, it's sort of now just given to us a little bit more mathematically, okay? So this is essentially saying that the angles found in here, the standard angles found in here are between 0 and 90 because this is 0 degrees and 90 degrees. This is saying any angle found in quadrant 2 is between 90 and 180, because that's true. This is 180. This is 90 degrees. So anything found in here is between 90 and 180. Then you got 180 and 270. So any angle in quadrant 3 found there. And then quadrant 4, the angles between 270 and 360, of course. Okay, so we have learned all about standard position angles. Now I'm going to pause the video here and I'm going to make a new video that is going to now introduce reference angles. Okay, so before you move on to reference angles, make sure you understand standard positions and how all of those work. Okay, so go practice a few standard position questions or send an email off to your teacher if you're confused, and we will go from there.